Good morning to all of you. Today we will continue our lecture of Bohr's atomic model. Bohr's first postulate says that electrons can revolve only some stable non-radiating orbits. And second postulate says that electron can revolve in only those orbits for which the angular momentum is integer multiple of h upon 2 pi. Here h is the Planck's constant whose value is 6.6 cross 10 to the power minus 34 joule second. And here n is the positive integer which may be 1, 2 and 3, which is a orbital quantum number. Here n is equal to 1 shows the first orbit of the atom, 2 second orbit of the atom, and so on. As we move higher, the value of n increases from 1 to other positive integers. Now we come to the third postulate of Bohr's hypothesis. Third postulate says that electron can make a transition from one state to another state. It may be from higher state to lower, or in other hand, lower state to higher state. When the electron make a transition from higher to lower energy state, the energy difference corresponding to the states is emitted in the form of photon. On the other hand, if the electron makes a transition from lower energy state to higher energy state, it absorbs the energy corresponding to the energy difference of both of the states in the form of photon. So the energy emitted or absorbed in the form of photon is equal to h, where h, as implies, h is the Planck's constant whose value is 6.6 cross 10 to the power minus 34 joule second, and here nu is the frequency of the photon emitted in the process of transition of the electron from one state to another state. Here the value of nu, as we know that, is directly proportional to the frequency. As the frequency of the photon increases, the energy also increases. On the other hand, if the energy difference is high, the frequency of the photon emitted or observed will be high. Here E is equal to h nu. On the other hand, we know that by mechanics, L is equal to mvr. This is equation A, this is equation B, and this is equation C. From equation A and from equation C, we can see that mvr is equal to nh upon 2 pi. By that formula, we can calculate the radius of the orbit of electron on which the electron is revolving, and V shows the velocity of the electron revolving around the nucleus, and by putting all these values we can calculate these values, and we can also find out the energy by using the equation B. Thank you very much.